In the next 3 minutes, I'm gonna show you the story how Google actually took an outlier models and makes something genius. And look at this leaderboard right here. On the ALO rankings, and Gemma 4 caught my eyes because this version basically started picking up my attention. 1451 score. But look at the Kimi right next to it, because apparently this thing is way bigger, and Gemma 4 actually only has 31 billion parameters. Like, what the hell, bro? I thought all the numbers actually looked super weird at first, so I immediately got started reading some papers. And then I'm gonna show you how Google completely break the benchmarks and why developers are getting robbed right now. Look at this. Google actually released Gemma 4 under Apache 2.0. The license basically means people can take this version for free and works on your phone. People are actually missing out a lot of money if they don't take this opportunity, while other models stays restricted. Gemma series actually has already 400 million downloads, but I actually want to know how the models stay efficient, and then Google released 4 version. Basically, E stands for effective. Then my argument is that running a model on a $50 Raspberry Pi is a game changer that saves you $1,000 for a cloud version. And I thought probably there was a huge demand for this kind of model, while other companies still has to think twice, right? It's fucking brilliant. But you actually have no idea what happens when the data starts moving and how Google find a new way inside the chip. So I want to show you the story of how Google actually used TurboQuant to find another way to handle memory bottleneck. And I'm clicking on the part of the document where they use polar quant right now. And look at this math. Actually, Google changed the vector space from Cartesian X and Y coordinates to polar radius and angle. And this process keeps the accuracy high while reducing the file size. The team also actually used HGL to project high-dimensional data into 1-bit representation. And this process turns complex math into simple +1 or -1 signal. And these changes actually make the calculation 8 times faster. Honestly, this version is kinda old but better, which is pretty good sign for a model that has a huge parameter. But listen to me, what's the point of being fast if the brain is old? The AI industry has been scammed, making you believe that your hardware is so weak and you need to buy something new, but Google actually finds a smart way. And get ready to be pissed off when you see where they actually hide the rest. And look at this part. The model is listed as 2.3 billion parameters, but Google actually put an extra 2.8 billion parameters in the flash memory. This is basically genius idea. This doesn't count as active parameters because the system only loads them into RAM when the specific layer is revealed. Basically, this method uses storage to increase the knowledge base without extra RAM. You actually get a result from 5 billion parameters model. Well, the hardware thinks it's only running 2 billion. Like, what the f, bro? And look at this. On an RTX 5090, Gemma 4 is 2.7 times faster than all Mac M3 Ultra. Google is actually building this for local hardware rather than just for some cloud server. In my opinion, if you're still paying monthly subscription for those massive models, you're actually just missing out a lot of money. Anyway, if you like this video, please support me to subscribe and comment. See you in the next one.